Hello, Go 1.27 has just been released, and I want to show you three of the most important features in this release. So stay tuned. This video is going to be short, so you don't have any reason to click away. You don't even have to type, just watch. All right, first, let's start with generic methods. I'm going to now move away this, and then I'll show you the problem that we used to have. When you come here, so by the way, I have Go. You see, I upgraded my Go to 1.27.0, which you can download from the Go website. So before, this is what we used to have. When you create a generic type, let's call this slice. So you supply the placeholder type and maybe something that returns a slice. So this can be a slice of int, a slice of string, a slice of anything, right? This is a generic slice. Okay. Now, before, if you are going to, let's say, this is before Go 1.27, if you have a method like this, and I'm going to bring this over, let's say we want to add a method to it. You don't need the any here. And you do map, let's say we want to create a map method. It was impossible. Of course, I can put anything I want to put here, right? Let's say whatever I want to put here. It's just a function. But it was impossible to come here and do new generic. So you can't come from here and say, okay, maybe you need to accept a U any. So you cannot add another generic type here. So that means method does not support generics. That was before Go 1.27. So what we usually do was, for example, we come here. This is like a workaround that we do, right? We come here and we say, this is just a plain function. This is not a method. So we do a plain function and we accept more generic like this, right? And we can save the values that we want to, and then bring the slice here now of type T, right? And maybe how we want to transform it. And the function will take T, of course, and return U, and of course the slice. All right, I can put U here. All right. If you are not very familiar with generics, don't worry, you can just watch. But the most important thing is, you see, we are unable to add the function to this type as a method because we needed to add additional parameter, which the Go doesn't use to support. Then, of course, if you want, you can write the code here now and do. The code itself is not that important, but I'm going to write it anyway. So slice view. Let's allocate some memory here, and then the length of the values that they are sending in. Okay, and after that, we just loop, and then we can transform it. I think that is okay. I can call it range values. I have the I and the value, so I'm going to say results. Because we have the memory allocated here at index I, we're just going to call transform, and then we pass it the value. This allows us to supply any function for the transformation. We just return the result. Okay, and with that in place, we can use it, right? Let's say I come here, I can say numbers, slice of int. This is just what we did, maybe, I don't know, 727. You can supply anything you want. And let's now transform it. Let's do like label the function. We are going to receive the number in here, one of these. So each of these will be passed to this function when we pass the function. And it will return a string. We are creating this function inline here. And what we are going to return is maybe item dash the number that they are passing, strict conf. Pass it the number. Okay, then with that, we can just print something out. Print ln. And what do we need? I can say, so before 1.27 example for now. Let's just put it like this. And then we call map and we pass it the numbers and then we pass it label. That's it. Sorry, I need to put a comma here. So this is going to work for sure. I can clear my, then I just run go. So go, you see, we have it transformed. So basically we are passing this, but the difference is that this map does not belong to the slice type. So what if we want it to belong to it? Now what we can do, the same thing, I'm not even going to change it. What I'm going to do now, it will be neater. So this is after go 1, this is after go 1.27. Now we can do as simple as this. So func, the values will come in the slide. So we are going to do it like this. Then this is the map now belongs to that type. But the function that we want to use for the transformation, we can also make that one, make it generic now by calling it u any and then transform func is going to receive the data u and of course u. Then what do we want? If we look, honestly, if we want, we can write it. We can just do the same code in here, but why should we do that? Let's just call this one here and then transform. So the good thing now is here, I can duplicate this line so easy after go 1 point. So here, we don't need to do this anymore. We can call these numbers because it's of type slice. We just say numbers dot, and we have the map and pass it the function in here. You see, the same, it works. For me, this is the joy of working with Go, because even though they're giving us this new feature, the old one is still working. It's not, your code is not going to break. Nothing is going to happen to your code as long as Go is concerned. There is always backward compatibility. That is a promise. But for me, the takeaway regarding this generic is basically the fact that you can now add this generic now to the method. This is a method, this is a function, two different things. You know, this method map belongs to the slice. So you cannot use this one, this implementation, without this. So you see that we call numbers.map. That is the difference. But here we didn't call numbers.map. Map is an independent function that takes this as an argument and also the function as an argument. You can even define the function inline like this and do something with it, you know. So that's it for this generic method. And then I want to show you the second thing. Please stay and watch it completely because something else is coming at the end, which I think is super interesting. So let's look at the second one. Welcome back. The next thing is promoted fields in struct. What does that mean? So basically, I think I can, maybe because some of you might want this code. It's quite a small code, so I'm just going to delete it. If you follow the first part, then you should have typed it out. So use promoted fields in struct literal. So that's what it is. So let me show you what the problem is. So let's say we have type here called contact. There's an example on their website that says this. You know, you have a string here, and you have another type here called user struct, and you have a name string as well, and then we have a contact. This contact is embedded. All right. Now, the problem is this: when you come here, this is before go 1.27. what you are going to do, let's call this one before, and then we say user, right? And we're going to say name, Joseph. And then the contact, we're going to supply the contact. Please forgive me if you're hearing some screaming. The kids are on holiday, so they're screaming outside. Then you have to do this, right? Joseph at, so let's say some test. Please don't try to send an email to this. It's just random. And so this is what you would have done. And of course, we can try to print it out. I can do it like this before. Let me put a new line. Bring my terminal, clear it a little bit, tab up, press it, and then you see the contact is there and it's working. There's no big problem with it. But personally, I have a problem with this long typing here. I have a problem with this. Thanks to the community, they now fix it. So after Go 1.27, we can simply just do this now. So let's call this one after. So user name, let's say Joseph 2. And now email, you see, Joseph 2, blah, blah, blah. There's just some random. Please, like I said, don't try to send an email to it. And we copy, paste. So we can now say before, after, run it. You see? The same output, the same behavior, but less typing. You see, we are able to reference this email directly from the contact, and we don't have to specify the contact, this long typing anymore. For me, this is a super shortcut that I think is very, very good. And of course, you can as well just call .email. You see, it works. If you want as well, you can also, if you can take the long route, if you have a lot of time to waste, you can do that as well. But trust me, a lot of people would prefer this short version now. That for me, it saves a lot of typing. So that is the second feature. Now let's look at the third one. So this is the third one, and I want to try and clean up what we have done in the last part. And you see, so this third one is a little bit confusing. Let me open up the website and just show you something quickly. Here it says that finally, function type inference has been generalized to apply in all assignment contexts. So what does it mean? I want to show you what it means, right? So let's say, let's have something here called label, and let's say label, and we have, this is just a function that label value will be t and returns a string. There's nothing special about this. I can just printf whatever they pass in. We can see the value is equal to positive v here, and then this is really simple. Let's print something out now. I'm going to do this and then say label. We can call label with 10 and run the code. You see 10 is printed out. I just put a new line here quickly. So 10 is printed out, but you can as well call label with test, or whatever. So that is a string. You can as well call label with a boolean. Let's say true. Okay, that is the power of generics, right? Because this creates a generic value. But here is the thing, where the type inference comes in. So let's have another function type here called formatter. This is just a function that Yeah, this signature means any function that takes an integer and returns a string. So this is just a signature, but we are giving it a name called formatter. Here's where the problem is. Before Go 1.27, the only way to do it is this. So before, again, we can say, let's create a slice of formatters. And then we give it, remember here, we can satisfy this function by saying, look at what we printed here. If the value here is 1 or 2 or 12 or whatever, this integer that returns a string will satisfy this. That means we can add it here like this. How do you add it? If you do it like this, this is, so before Go 1.27, this is how you can do it. You must supply this int here to satisfy this signature, because this is a generic function that can be here, can be Boolean, can be anything. So before Go 1.27, you must specify this int, right? And since you have it here, we can take the first value. Let's print it out. Yeah, I can just do that. Data before, and I put a backtick like this. I can say before is a slice of formatter, so I take the first value and then I just call the function, and I must call it now with int. You see, it's telling me to call it, so I can call it with 100 and run it. So this is before Go 1.27. This is going to work in even this current version and old version is going to work. But like, honestly, this is a lot of work. So after Go 1.27, the Go community has now made it in such a way that we can just bring it here. And I don't need to put anything here. I just say label, right? But what is going to happen is when I call it here, when I call it here and I specify something long, it works because automatically, this is where the inference come in. The compiler, at compile time, this is not at runtime, based on the documentation, at compile time was able to infer and fill in the type for us. So it's filling in the type for us that this is an integer. That means the compiler would do this for you because it saw an integer here. It's a good. But let's say, what if we go here, because we know for sure that the label is generic, and you go and you do this. This is a test. Of course, as you can see, it's already screaming at you that, hey, what are you trying to do? The formatter that you're trying to create requires an integer. So why are you putting a string here? So it's not going to work. So and this is the most interesting part, right? Since it knows that this is a string at compile time, and if can know that this is also an integer at compile time, it doesn't make sense specifying it here, or rather we can say it means it has enough information to fill in the gap for us. And that is it for the type inference. 3 features that I personally will be using because I think they are important. The generic method has been one of the most important features that I've always been looking out for, and finally we have it. So I'm really, really happy. The way we can now use the struct feed from the embedded struct directly, it's also very powerful. And then finally, this type inference that we have here. All right, thank you for watching. If you like my videos, I have the Go Masterclass on Udemy. If you are not following this channel, please can follow. A lot of people don't actually follow me, so it's no problem. I'm not on YouTube making any money. So if you don't follow me, no problem, but just like the video. I'll see you in the next one.